Here on the channel. In today's video, we're going to be taking a look at question 6 from the 2023 Specialist External Exam Paper 1. Now, you would have noticed on the channel I've started splitting up the questions into individual videos. This way you guys have a bit more variety in terms of your study material. So pretty much if you only struggle with certain types of questions, you can go watch those ones, rather than sitting through a full external exam video waiting for your question to pop up. In saying that though, the full external exam is still up on YouTube. The link is in the description below. If you need a specialist external exam bundle pack, the link is also in the description below. And then also, I think the playlist to everything for specialists is in the description below. And then if you have any questions about this one here, leave something in the comments and I'll try my best to answer you. Okay, now that that's all said, let's get straight into question 6 here. So here, the shaded region defined by this here, best is represented by, and we're given some options here. So first of all, sketching a complex subset is not that hard. It looks hard, but it's not that hard at all. This information here is just saying you are sketching in the complex realm, okay? This is basically saying you are only accepting the real complex numbers that are less than 1 here. But first of all, let's talk about this guy here. Let's sketch this. So here, basically saying z plus 2 minus I, the length of that is less than or equal to 5. A complex number, we've got to convert this into its generic form. A complex number is a real, which we're going to use x for because it's horizontal, and yi, which is imaginary part, which we're going to use for the vertical part. What we do is we chuck that into there first of all, okay? Now, I'm going to make the question itself a bit smaller, that way I can write a little bit more. So once we do that, it's going to allow us to start working out what this thing actually looks like. Now, hopefully you can start to see what it will look like before I even do this, but if not, that's fine as well. So here you have x plus yi plus 2 minus I. Alright, what you then want to do is group the imaginary terms together and the real terms together. So the yellow are your imaginary terms and the blue are your real terms. Once you do that, you've got x plus 2 plus y minus 1i. Now, it's just actually finding the length of a complex number here. To find the length of a complex number, it's just like a vector. You square root and square each of the components, but you don't include I because I is built into the axis there. So you square root and you square each of these guys here. Now, hopefully you can see this is starting to look like the equation of a circle. Then all we do is move it to the other side. So here we have x plus 2 squared plus y minus, oh, that's a squared there, minus 1 squared less than or equal to 25. So here we can recognize this is the equation of a circle with a center at -2, +1. So here the center of our circle is -2, +1. It's the opposite signs of these bits here and has a radius equal to 5. So first of all, to work out our correct answer, we look at which circle of our answers matches our center. So we're at -2, which means we're to the left-hand side. Now these ones here would be at +2. So these are going to be incorrect straight away. So I know C and D are incorrect, okay? So that leaves us just with A and B. And we can see they match our center here because they're probably at -2 and it looks like +1 there for both of them, which matches. Now, the next bit that's important is the inequality. It's basically saying we want every complex number that is less than or equal to 25, which is just 5 in this case here. So, at the center, every complex number that is exactly 5 units away from it. That's why you get that outline there, okay? Now, notice how both of the regions are shaded because you've got this second thing here. You're only also sketching, so in this sketch here, this is what we would have at the moment. So if I were to put it down here with anything, okay? We have a circle. I will go link to shape. Let's do a circle. That is a terrible circle. I'm going to get rid of that. Let's try a better one. That's perfect, okay? So we have a circle that's sitting, now I can't even move it. Oh, it's right there. We have a circle that's sitting there, okay? And we want the shaded region for which that is less than or equal to 5. So that would be this entire region here. However, we've also got to establish this second bit here. We only want to overlap with the complex numbers whose real part is less than 1. So in this case here, this symbol means real, and when it says a z there, it means real complex number. So the real part of the complex number has to be less than 1. So what that means is, because this is the real axis and this is the imaginary axis, you've got to find where 1 is positioned. Now 1, if I were to move the circle a bit over like this, oh, that's kind of wrecked the whole thing. That's okay. 1 is probably about there, which is why they've got this line here on each of the questions here. Now when it says every complex number that's less than 1, that's why there's also a dotted line there on either side here. And anything less than 1 is going to be on the left hand side of it, because anything above that is like 2, 3, etc. So this is actually incorrect, because they've got the shader region for which complex numbers, the real components, are bigger than 1. This has our circle, and it's got every complex number whose real component is less than 1. Okay? That's a hard question to do, and they could also make that a short response question as well. If you have any questions about this one here, you need to learn how to sketch complex subsets. Okay? You also may need the Specialist External Exam Bundle Pack. Who knows? Link is in the description below. If you have any questions about this one, you leave something in the comments or you send me through an email. But otherwise, I'll see you in the next video.